Tiling a shower. Yeah, I do tile work on the side when I can. Yeah. It appeals to my working with my hands and working with math and thinking through problems. Sometimes it makes me want to throw tiles through the wall, stuff like that. No, not really. P hat. I'll define P hat in just a second. Well, in fact, this is the definition, but we'll make it a little easier. Is x over n, excuse me, which is the count of successes in a sample divided by the sample size. So it's a proportion. This is the sample proportion. Which makes it a parameter or a statistic? Statistic, right. Okay. Now, there's a mu of p hat. This is the easiest mu there is in all of stats that I know of. It's just p. What's p? P is the population proportion. And we also have a standard deviation of p hat, which also isn't too bad. Sigma p hat isn't quite as easy. It's p times 1 minus p divided by n, and take the square root of that. So the parameter p, the statistic n, it's all you need. And these two guys we can use if rules 1 and 2 are true. Or satisfied. Now, you don't know what rule 1 and 2 is yet. Actually, we've kind of seen them before, but it's been a little while. Always makes me think of Thing 1 and Thing 2 from Dr. Seuss, right? Rule of thumb number 1. I also think stats is cool because they have something called the rule of thumb. I mean, if you go talk to somebody who has a doctorate in statistics, and you say, hey, what about that rule of thumb thing? They go, yeah, that's pretty cool, huh? Right? I mean, it's like this sort of informal thing. It looks it. At least it's named informally. I like that. We can use sigma p hat only when the population is 10 times as large as the sample. I should say only when the population is at least 10 times as large as the sample. Actually, that's not totally correct either. How about I say 10 times or more as large as the sample. So, in this case, big N, which is our population size, has to be greater than or equal to 10 times our sample size. thumb number 1. Now, something to say about this rule is oftentimes it's assumed. For example, let's say I want to take a random sample of 500 U.S. adults. Do I really need to show or prove that there are over 5,000 U.S. adults? No. It's reasonable to assume that rule of thumb 1 would be met at that number. Does that make sense? So oftentimes we make some assumptions here. All right, rule of thumb number 2. Rule of thumb number 2 says we will use the normal approximation to, am I talking about normal approximation, right? To the sampling distribution of p hat for the values n and p that satisfy n times p is greater than or equal to 10, and n times 1 minus p is also greater than or equal to 10. So if you've got both of these, you can use standard deviation. If rule of thumb 1 is good, rule of thumb 2 says it's normal. The sample size and the proportion is enough to be normal. And so what that allows us to do is then, if the rules of thumb are satisfied, then the data is normal and we can standardize using table A. So a couple things I just want to kind of mention. In statistics, P is kind of one of those do-it-all variables, right? A couple chapters ago it was probability, and now it's proportion. So you have to look at the context of the situation to decide, is P proportion or is it probability? So in many ways that can be kind of difficult at times. One little short bit more on the notes, and then we will do a problem. Everybody ready? Got that? Okay. All right, let's continue on with the notes. So we can standardize if the rules are met. We haven't used proportions yet. We've used what we think of as counts. And our standardizing formula for counts, we should know very well, right? We get the z-score, and then we take the z-score to the table and figure out the probability. Now, this is for counts. We're looking at proportions now. So this would be then p hat minus p over sigma p hat equals z. So p hat being your sample proportion, p being the population proportion, and sigma p hat being the standard deviation. You have to calculate this guy. It's probably not going to be given. Now we have to calculate that one. Okay. Good? So let's look at a problem. 919.
Mr. Kelly needs a calculator.
No, I'm sorry, who?
Mr. Kelly.
Oh, yeah, go ahead and take one of those. You think he'll be able to figure that one out? He is an English teacher.
Yeah.
That one might come back to bite me.
Yeah.
You think?
Yeah.
Mr. Kelly and I are good friends. He's crazy. Okay, this problem is asking, do you drink cereal milk?
Yes.
Well, yeah, of course, right?
Yeah.
Isn't that the best stuff?
Yes. I thought it was asking like if it's milk in your cereal, like better yes.
I mean, oh yeah, especially the bottom of the bag of some sugary cereal like Frosted Flakes or something like that. You know, you take that sugar and you dump it in, right? And you milk it up, and then there's all that. It's like sludge on the bottom, but it's awesome sludge, right? You can't. You got to drink the milk, especially. And if it's a non-sugared cereal, the whole point of non-sugared cereal is being able to add as much sugar as you can, right? Without your mom going, "Hey, get your hands out of that sugar. That's too much," right? That's the one thing about being an adult that's cool, is you can add as much sugar as you want to stuff. Sweet. I don't recommend it, but you can do it. Okay, so this problem says, a USA Today poll asked a random sample of 1,012 U.S. adults what they do with the milk in the bowl after they've eaten the cereal. So I'm going to make a note here. N equals 1,012. So we've got 1,012 adults. Of the respondents, 67% said they drink it. So 67% of the respondents said they drink it. Is that proportion, is that the statistic p hat, or is that p? That's the statistic, right? So that's from the sample. So that's p hat is 0.67. And then it goes on to say, suppose 70% of the U.S. adults actually drink the cereal milk. That's your p. P equals 0.70. Okay. Find the mean and standard deviation of the proportion p hat of the sample who say they drink the cereal milk. Okay. Well, mu of p hat is just p. So it's 0.70. Or 0.7 if you want to drop the 0, that's fine with me. That's the easiest mean calculation there is. It's p. So sigma p hat is the square root of p, 0.7, times 1 minus p, 1 minus 0.7, over the sample size. So I'll go to the calculator here. I'll do it this way. I'm going to go square root 0.7 times 1 minus 0.7 would be 0.3 divided by 1012. Make sure it all falls under the radical. And I get 0.0144. So far, so good? Okay. All right. B asks us to check and see if rule of thumb 1 applies. Explain why you can use the formula for standard deviation of p hat in this setting. Rule of thumb 1. So rule of thumb 1 is n 1012 times 10, thank you, greater than or equal to, less.
It's n multiplied by p.
NP, yeah, sorry, thanks. I've been doing this too many times and it's blocking through my mind. No, it's not. 10 times is that, Liam, shut up. You're just doing more to confuse me. You're right. 10 times n, well, that's what I had. 10 times n has to be less than or equal to n, big N. Okay? So the population has to be at least 10 times bigger than the sample size. Now, we're talking about U.S. adults here. Is it reasonable to assume that there's more than about 10,000 U.S. adults? Yeah, I think we're good here. We can check this. This is reasonable to assume. Okay. And then C asks us, so we can use our standardizing formula. So this is valid. So C asks us to check rule of thumb number 2. Is 1012 times 0.7 greater than or equal to 10? Yeah, 70% of 1,000 is definitely greater than or equal to 10. I don't need you to calculate this out. And I don't think anybody reading the AP exam would need you to calculate this out. Just show that you've checked it. Okay? Yeah, that's true, right? And then 1012 times 1 minus 0.7, p, is also greater than or equal to 10, right? So if these are both true, they both have to be true. If they're both true, then we have a normal situation. We can use the normal curve and table A and all that. All right, D. D says, find the probability of obtaining a sample of 1,012 adults in which 67% or fewer say they drink the cereal milk. 67% or fewer, that's standardizing. So this is going to be p hat minus p divided by sigma p hat, which we've calculated up here, 0.0144. And that's going to give us a z-score. I get negative 2.08. So I'll go to my table A. I have more table A's if you need one. I'll get you one here in a little bit if you need it. So if I go to table A and I go to negative 2.08, I find that that's 0.0188. So looking at this in terms of a curve, 0.7 is my mu, right? It's the middle. 0.67 is way over here, where I only have about 2% of the curve shaded, less than that. So the next part of this question D is, does that cast doubt on the sample proportion, or the sample itself? Yeah, we would expect this to be closer to 0.7. So I think that it seems like maybe there is a problem with the data collection or something like that. It seems like this is a great way of answering questions in AP form. They like seems like. There could be a problem, or there is a problem. With the sample. Seems like there's an issue here, right? We don't know what it is, and we could make some guesses, but that's all they'd be. But that just plays the what if game. E says, what sample size would be required to reduce the standard deviation of the sample proportion to 1/2 the value you found in A? So I'm reducing the standard deviation, so I've got to use my standard deviation formula. So I've got ooh, a letter. Thank you. Awesome. Oh, right, Peyton. It's asking about sample size. We don't know the sample size for this. Okay. But we're going to half the standard deviation. So we're going to half this value here. So I'm going to just go ahead and do that. That's going to be 0.0072. Right? The question is, how big does the sample size have to be to half the standard deviation? Okay. So now I just solve that problem. What might be my first algebraic step here? Yeah, get rid of the root, you mean? Yep. We're going to square those guys. So I have 0.0072 x squared is actually going to be a smaller number. So this is going to be 0.7 times 0.3. I'm going to go ahead and simplify that over n equals 0.0005184. That's what that number is. there's a nice algebraic shortcut for solving a problem like this. I call it the trig shortcut, but that's just my name because trig uses it a lot. What's that? You don't know?
Multiply everything on top of the end.
You can do that. That's not quite the shortcut I'm looking for. If I've got a fraction equaling a number like this, and a variable is in the denominator of the fraction, I switch it. Yeah, somebody switch these guys. I call that the trig switch. So this just becomes n equals 0.7 times 0.3 divided by all this, which is going to give us a number. So I'm going to do this. In the calculator, I'm going to go 0.7 times 0.3 divided by the answer that I got up here. And I get 4,050.925926. How many people is that?
4,051.
Yeah, 4,900, or 4,051. Can't write. It's almost Friday. My hand's shot. With people, you always round up. Okay. Let's back up a second here and let's talk about this because this can cut you. There's a reason they have you do this. They want you to see something. I probably need to show it to you. So this number here, I rounded a little bit, yeah? I cut some of the numbers out. So I'm using a rounded standard deviation. This is half the standard deviation. And what I end up getting is a number. What relationship does this number have to the original n, which is 1,012?
Like 4 times.
Exactly. It's like 4 times. It actually is 4 times. But the reason this isn't 4,048 is because of rounding. So if you want to half the standard deviation, sample size has to be 4 times as large. That might be something to take a note on. I'm not going to write it down, but it could come in very handy for one of your problems today. Cut you out a lot of work. Okay. So 4 times the sample size halves the standard deviation. Okay. All right. I'm gonna leave you guys to F. F just says if the pollsters had surveyed 1,012 teenagers instead of 1,012 adults, do you think the sample proportion p hat would have been greater than, equal to, or less than 0.67?
Maybe lower.
You think lower? You think fewer teenagers drink the milk than adults?
No. I don't know the response in this classroom. Because with adults, it ranges from like wherever they start from until like wherever the teenagers like a pretty short.
Yeah, but now you're but the sample size is the same.
How often do you eat breakfast or cereal for breakfast? I eat waffles. Pretty late.
Okay, so if you were to eat cereal with milk on it, would you drink the milk? Let's take a quick survey.
Yes.
Yeah?
Wow, it's a lot less than 60.
Wow, maybe it would be less. According to this class, maybe it is less. I would say more. But I'm just a big kid, so. Okay,
Yeah.
I want to get you started. I want to get you started quickly on 922. I don't really know that there's a reason to answer F. It's kind of an open-ended thing. So listen to 922 because there's some stuff in here I want you to clue into. Harley-Davidson motorcycles make up 14% of all motorcycles registered in the United States. Is that the p hat proportion or is that the p proportion? That's P. You're right. It's all motorcycles registered in the United States. So this is P. Okay? You plan to interview, you haven't done it yet, you plan to interview 500 motorcycle owners, an SRS of 500 motorcycle owners. Now that's not a proportion, that's a number. That's n. Yeah, that's little n. Okay, so that's what we have. We're given 14% of all motorcycles registered in the United States are Harleys, and we're going to sample 500 of them. A says, what is the approximate distribution of your sample who own Harleys? Okay, what that is saying is, let me translate that for you. If you sample 500 people at random, how many would you expect to own Harleys? 14% of 500, which is 70. Right, exactly. You would expect 70. You should find 70 Harley owners.
What percentage of 500 is 5 multiplied by 14?
Okay. B. All right. B is critical. Listen. How likely, Liam, how likely is your sample to contain 20% or more who own Harleys? Do a normal probability calculation to answer this question. What is a normal probability calculation? When in doubt, standardize. A normal probability calculation is standardizing. If you look at table A, it says, it doesn't quite say it exactly like that, standard normal probabilities. Okay? That is your clue to standardize. So the 20% that they're giving you is your p hat. It hasn't happened yet. They're just saying, suppose you take your 500 samples. What's the likelihood? So anyway, hopefully that'll get you through that vocabulary.